In this video, we will be learning on solving 1 plus 1 on quadratic unconstrained binary optimization. We will be doing the coding in Google Colab. Like we did in the previous video, we will be starting with installation of Blueqat. Type the code !pip install Blueqat in order to install Blueqat. Let us do it in Google Colab. Type the code that was shown earlier and click on the play button to run the code. Blueqat will be installed after a while. Before starting the actual video, let us learn the equations used for solving 1 plus 1 using combinational optimization problem. Firstly, we want to solve the problem given in equation 1. This is equivalent to solve the minimum value problem given in equation 2, expanding it, and we get the equation 3. Besides this, the equation can be written in decimal number using 2 qubits binary value given in equation 4, and substitute equation 4 and 3 to get the Hamiltonian equation form given in equation 5 through expanding it, and we can make this equation simple by using binary rules given in equation 6, and finally we get the equation 7. We will use this equation to solve 1 plus 1 on QUBO. As we have already learned on quadratic unconstrained binary optimization on last video, which is a pattern matching technique used to minimize a quadratic polynomial over binary variables that are true and false states that correspond to 1 and 0 values, common in machine learning applications. QUBO problems may sometimes be well suited to algorithms aided by quantum annealing. Let us now solve 1 plus 1 on QUBO. The first solution is to get the QUBO matrix by locating every coefficient on the off-diagonal elements of the matrix, as you can see in the code given. And if you run this code, then we will get the output of QUBO matrix, which includes 0 and 1. Let us confirm this in Google Colab. Type the code that was shown earlier. Then click on the play button to run the code, and as you can see, we get our output as QUBO matrix including 0 and 1. The second solution is to do the same calculation by putting the equation 7 that we have earlier learned directly as Hamiltonian, as you can see in the code given. And if you run this code, then we will get the output of QUBO matrix, which includes 0 and 1. Let us confirm this in Google Colab. Type the code that was shown earlier. Then click on the play button to run the code, and as you can see, we get our output as QUBO matrix including 0 and 1. Lastly, let us solve 1 plus 1 on QUBO. We can write the decimal number using 2 qubits binary value in equation 4 that we have learned in the beginning of this video. From the two solutions, we got that the first qubit is 0 and the second qubit is 1. Then, by putting the values of 2 qubits in the equation given above, then we will get the decimal number 2 by solving 1 plus 1 using QUBO.